Okay, that is our first slide, which is fundamental slide. The title of the slide is Fundamentals of Microwaves. So in this slide, we'll discuss about the fundamental things of microwave, okay, microwave engineering or microwave and antenna engineering, whatever it is. We have to discuss about those things okay, in this chapter. And yesterday I have not taken your class, and I think tomorrow you have no class, right? Tomorrow, do you have any class?
Yes, sir. Yes, sir. We have two classes.
You have two classes.
Yeah. Power and engineering mechanical.
Okay. So which day you are free?
Yes, Saturday we free and Monday free. We are 2 days. 2 days.
Sunday
and Saturday.
Sir, Monday and
Monday to chutti. Except Monday.
Yeah.
Saturday and Sunday.
Yes, sir. No, Monday.
Saturday, what happened Sunday?
Sunday we have two class.
You have two class.
Yeah.
Okay. Thursday you have also class.
Yeah.
Not this Thursday, regular Thursday.
Yeah. Tomorrow we have class. Next day we have Friday and Thursday we have there's no class. Another Sunday we start our class. We have two classes.
Okay. Oh, then I'll take that class later.
Okay. If you want to take that.
Okay, so this is the fundamentals of microwaves. We'll check it out. So first of all, let's talk about the syllabus. What is the syllabus of your this course? What is this course? First, transmission and waveguides. We already discussed it in last class. That what kind of things we'll see, like transmission line and waveguides, analysis of high frequency transmission lines, losses and lossing, and different types of modern transmission lines, as mixture and its applications, impedance matching techniques and applications, guided EM waves, parallel plane and rectangular waveguides, cavity resonator. After that, we'll see the antennas and radiations, small current element antenna, long straight antenna, radiation patterns and gain, frequency independent and low frequency antennas. These are the types of antennas. We'll also see antenna arrays, broadside and amplifier array, phase scanning of antenna arrays, transit time effects, velocity erosion. Those things will be discussed. After that, if we get time, then we'll discuss about the microwave tubes, which includes klystron amplifier, multi-cavity klystron amplifier, reflex klystron oscillator, magnetron oscillator, traveling wave tube amplifier TWTA, which is known as TWTA backward wave oscillator BWO, and microwave network analysis. Finally, we'll see this, which includes that's actually scattering matrices and multi-port analysis techniques. Okay, these are the syllabus of your upcoming this course. This is the syllabus of this course, and we'll check this out. Okay. Okay, so you know the mark distributions as well. Presentation or quiz, those things will need 20 marks. Attendance 10, midterm assessment 10, midterm viva 10, final assessment, assignment 30, and final viva 20. Okay, you already know that. So I cannot say more about this. Okay, these are the books. Some textbooks are there. Fields and Waves in Communication Electronics, Simon Ramo, John R. Wenery, Peter Van Duzer. That is the first edition. First editions of Fields and Waves in Communication Electronics. You have to take it. And Foundations for Microwave Engineering, this is the second edition, Robert E. Collins. Applied by Robert, written by Robert E. Collins. These two books are important for this course. We'll check this out. Okay. So what we'll see today? Actually, we'll see what is a wave and classification of waves, microwave, pros and cons of microwave communication, applications of microwave, and Maxwell's equations. We'll see these things. Wave, classification of waves, microwave, pros and cons of microwave communication, and applications of microwave, Maxwell's equation. So first of all, what is the wave? I think you already know that. Do you know what is the wave? See,
Yes, sir. We know, sir.
Yes, sir.
Yes, sir. We know.
this is a wave. A wave can be described as a disturbance that travels through a medium from one location to another location. Waves can travel from one location to another. Okay. A medium is a substance or material that carries the wave. Okay. Which carries the wave? The medium. Air could be a medium. Okay. Air medium. And some other mediums are also there. So lambda is the wavelength. This y is the amplitude. Okay, y is the amplitude. Lambda is the wavelength. Okay, so wavelength is the difference between two successive maximum points or difference between the two successive minimum points. This is the wavelength. This is also wavelength. This is also wavelength. But this difference is measured as the wavelength. Okay, so this is a wave, and for carrying the wave, we need a medium. Okay, for carrying the wave, we need a medium. So a wave can be described as a disturbance that travels through a medium from one location to another location. Okay, so wave can be described as a disturbance that travels through a medium from one location to another location. A medium is a substance or material that carries the wave. Okay, I think you understand the thing. And classification of waves. There are two kinds of waves are there, like the mechanical wave and the electromagnetic wave. Okay, so what is the mechanical wave? A mechanical wave is a wave that is not capable of transmitting its energy through a vacuum. So mechanical wave cannot transmit energy through vacuum. And mechanical waves require a medium in order to transport their energy from one location to another. A sound wave is an example of a mechanical wave. See, mechanical wave, sound wave is example is a mechanical wave. So it cannot pass through the vacuum. But electromagnetic wave is a wave that is capable of transmitting its energy through a vacuum. So EM wave can transmit its energy through the vacuum. So if I ask you what is the difference between the mechanical wave and electromagnetic waves, can you say this? I think you can.
Yes, sir.
And say electromagnetic waves are produced by the vibration of charged particles. So if you want to produce the electromagnetic waves, then you need to vibrate the charged particles. Okay, so charged particles like electrons. Okay, do you know how the structure of the electrons? That is a nucleus, shell, first orbit, second orbit, right? That is positive, and here could be negative one. These are the electrons, okay, like this. So electrons move around a shell on an orbit. It has an orbit, and it is a neutron. So nucleus, right? Nucleus, and nucleus has two things: neutron and proton, right? Neutron and proton. Nucleus has neutron and proton. Whatever. So electromagnetic wave is a wave that is capable of transmitting scientific wave vacuum, and not capable. It is not capable, and it is capable. See, that is the main difference between the mechanical wave and electromagnetic wave. And electromagnetic waves that are produced on the sun subsequently travel to Earth through the vacuum of outer space. See, EM wave, which is produced on the sun, it comes through the vacuum into the Earth. Some examples of the electromagnetic waves are microwave, X-ray, infrared, etc. Some examples are EM wave. Examples of EM wave. EM wave. Examples. Some examples are microwave. Micro. Okay, some examples are microwave. The other examples are microwave, X-ray, infrared, okay, these are the things. Microwave, X-ray, infrared, etc. These are the classification of types of the EMFs. Okay. So I think you have got the idea what is the mechanical wave and what is the electromagnetic wave. Okay. Munir, are you there? Munir, he is missing. Mithun. Mithun. Mithun ke aso? Mithun.
Yes, sir.
Okay, tell me what is the main difference between mechanical and electromagnetic wave?
Yeah, these are differences. Mechanical is a cable of transmission with through vacuum. It is a medium to transport energy. And electromagnetic wave is cable transmission through wave energy, and it doesn't need any medium.
Vacuum, it can transmit through the vacuum. Okay, so it is the main thing. So it can transmit through the vacuum.
Hello, sir.
Yes.
I think
mechanical wave is needing media.
Yes, it's needed medium.
Yeah, and electromagnetic it does not need any media.
Medium, yes. But if there is medium, it can also pass. Okay, see, that is the electromagnetic wave figure. See this figure very carefully. These are, see, electromagnetic. That means what? Electric field and the magnetic field. Two kind of fields are there. So electromagnetic means electric field and the magnetic field. So two kind of fields are there, and electromagnetic wave consists these two: electric field and magnetic field. Okay, electromagnetic wave consists these two: electric field and the magnetic field, and that is the direction of propagation. That is the direction of propagation. So that is the electric field, and that is the red color is the red line. Those are the magnetic field, and the blue lines, those are the electric field. Okay. So as we know, what is the wavelength? These two, the maximum point, the difference between two maximum points are known as the wavelength. So that is the wavelength. Okay. So do you know the polarization? Do you have any idea? Vertical polarization.
What's that?
Polarization.
No, sir.
Polarization. Polarization means, let's say that is our Earth space, right? This is our Earth space. If the electric field moves upward or downward, that is vertical polarization. Vertical polarization, this kind of polarization. And if it moves horizontally with the Earth surface, then that is horizontal polarization. Horizontal. If it moves circularly, that means this kind of polarization, this is circular polarization. Circular, like this. Okay, I'll show you the picture, but I cannot write this difficult. Okay, circular polarization. So these things are vertical polarization, horizontal polarization, and the circular polarization. Okay, so whatever. So that is your electric field, blue color, that is vertically, right? That is vertical, and the magnetic field, that is horizontal. Vertical means it makes 90 degree on the Earth surface, and horizontal means parallel to Earth surface. Two things. So that is the vertical polarization, electric field, and that is the horizontal polarization in the magnetic field. But the direction of propagation, which is the circular. So direction of propagation is here. It will move forward. It will move this way, in this direction. So this will move this direction. So that is the direction of propagation. Okay. So electric field and the magnetic field, and that is the wavelength, and this is the direction of propagation. Okay, you got it. What look like the electromagnetic wave? I think you have the idea already.
Yes, sir.
But unfortunately, during the Viva, some of your friends did not answer well. So correctly. Okay, so a few more waves. Some waves are there, like a transverse wave is a wave in which particles of the media move in a direction perpendicular to the direction that the wave moves. Transverse wave is a wave in which particles of the media move in a direction perpendicular to the direction the wave moves. Longitudinal wave is a wave in which particles of the medium move in a direction parallel to the direction that the wave moves. See, longitudinal wave is a wave in which particles of the medium move in a direction parallel to the direction that the wave moves. So one is parallel direction, one is perpendicular direction. If it is perpendicular direction, then it is the transverse wave, and if it is parallel direction, then it is longitudinal wave. Surface wave. What is the surface wave? It is a wave in which particles of the medium undergo a circular motion. See, so these are the polarization. Particle polarization, perpendicular, horizontal polarization, parallel, circular motion, circular polarization. Okay, so it's a wave in which particles of the medium undergo a circular motion. Surface waves are neither longitudinal nor transverse. Surface waves are neither longitudinal nor transverse. In longitudinal and transverse waves, all the particles in the entire bulk of the medium move in a parallel and a perpendicular direction relative to the direction of energy transport. See, in longitudinal and transverse waves, all the particles in the entire bulk of the medium move in a parallel and a perpendicular direction relative to the direction of the energy transport. In a surface wave, it is only the particles at the surface of the medium that undergo the circular motion. The motion of particles tends to decrease as one proceeds further from the surface. So these are the few waves. You just read it out, then you will see some basics. Okay, now look at here. Our electromagnetic spectrum. That is our visible spectrum. 400 nanometer to 700 nanometer. 700 nanometer terms as the red color, and 400 nanometer is the violet color. Okay, so 700 nanometer is the red, and 400 nanometer is the violet. So that is the visible spectrum. So that is our visible spectrum. Okay, and other spectrums are there like microwaves, infrared, ultraviolet, X-rays, gamma. These are the harmful. These are the harmful for the human body. And these are the radio TV. 300 kilohertz to 300 gigahertz. Microwave. What is the range of the microwave? 300 megahertz from these to 300 gigahertz. That is the range of microwave. Range of microwave 300 megahertz to 300 gigahertz. That is the range of microwave. And that is the range of infrared. That is the ultraviolet. That is X-ray, and that is gamma ray. These are the rays. Some spectrums are there: radio, TV, microwave, infrared, ultraviolet, X-rays, gamma rays. Okay, and that is the power. Voltage, actually, nano electron volt. If we term this one as the electron volt energy, then we can term it. See, wavelength in meters, nanometers to meters, and frequency in hertz. Okay. Energy in electron volts. So if I ask you what is the visible spectrum, then you should answer correctly. The range of the visible spectrum from the 700 nanometer to 400 nanometer. Okay, 700 nanometer to 400 nanometer. That is the visible spectrum. I think you should.
Okay, sir.
Okay, so you understand what is the visible spectrum?
Yes, sir.
Yeah.
Don't forget it. What is the range? 700
700 to 400 nanometer.
nanometer. And 700 is the red, 400 is violet. Okay, do you remember one thing which is deep gear?
Again, sir.
Deep gear. Something like the deep gear. Do you remember that? Or have you ever read this one? Deep gear. Have you listened it? Deep gear?
No, sir.
Wrong dhomo. Deep gear. Violet. B means violet.
Violet, yeah.
Violet. I means what? Indigo, right? Violet, indigo,
Indigo, blue,
indigo, blue,
blue, green,
yellow, orange, and red, right?
yes, sir.
And remember, big gear, big gear.
Picture, yeah.
So big gear is there. Violet, red. Violet, red. See, that is the big gear. Who is here? Green, yellow, orange, right? Violet, this is violet, indigo, blue, green, orange, yellow, orange, and red. So that is the video. I think you would remember this thing. What is the video? Yeah.
Yes, sir.
Okay, don't forget it. If we look at shorter wavelength, higher frequency, longer wavelength, lower frequency, these things. And some applications are there. See, AM broadcast, shortwave radio band, FM broadcast, GPS, microwave bands. Some examples are there. And this is the band designations. Band has names like L band, S band, C band, X band, U band, K band, K band, U band, B band, E band, W band, F band. Okay, these are the specific band. Okay, some parameters of microwave, like what is the microwave? Microwave is it is a short wavelength radiation and frequency range is 300 megahertz to 300 gigahertz. Okay, frequency range of microwave is 300 megahertz to 300 gigahertz. Wavelength range 100 centimeter to 1 millimeter, and can be reflected by conducting surface, line of sight communication, and it propagates through ionosphere. Due to line of sight and high frequency, fading effect is very low. Flickers smaller antennas. Okay, since it is high frequency, so it flickers smaller antennas. Transmitter receiver power requirements are pretty low at micro frequencies. See, low power. We can use the low power devices here. Can be focused in a specified direction. We can focus in a specific direction. It has a large bandwidth and the required obstacle is present in the transmission path. So the required obstacle is present in the transmission path. The cost of implementing the communication infrastructure is high. And microbes are susceptible to rain, snow, electromagnetic interference. Okay, so if you have the rain, snowfall, or the other electromagnetic source, then it will interfere with the microwave. Okay. Microbes are susceptible to rain, snow, and microsystem. The microsystem normally consists of a transmitter subsystem, including a micromodulator, waveguides, and see, this is the microsystem. You can see this in the laboratory. That is the microwave source. That is the wave meter. Then that is the calibrated attenuator, transmitting a horn antenna, receiving horn antenna, and output oscilloscope to the power meter. This whole thing, those things are there in our laboratory. So what it consists? It consists of a microwave source, a wave meter, calibrated attenuator, transmitting horn antenna, receiving horn antenna, output oscilloscope, or power meter, waveguide, transmitter, and crystal mount. These are waveguides. Okay. So a microwave system normally consists of a transmitter subsystem, including a microwave oscillator, waveguides, and the transmitting antenna, and a receiver subsystem that includes a receiving antenna, transmission line, or waveguide, okay, and a receiver. Okay. I have a call. Just a minute. Okay, so that is the microwave system. It has the microwave source and microwave meter, and it has a calibrated attenuator, and it is the transmitting horn antenna, receiving horn antenna. And you see, as a microwave source, we do use three kind of sources. There are three sources, like microwave source, like three source Flagstone amplifier, Flagstone amplifier, Flagstone amplifier, solid state gun oscillator, solid state gun oscillator, and another one is magnetron. Okay. These are the Flagstone amplifier, solid state gun oscillator, and magnetron. These three things are there. Okay. So these are the source of microwave, and in the lab we do have these two: Flagstone amplifier, solid state gun oscillator. These two are in the lab, and magnetron. And magnetron is in the. We do not have the magnetron. You can find the magnetron in the microwave oven. You can find the magnetron in the microwave oven. And wave meter, you will get it in the lab. And we have two kind of attenuator. One is fixed. One is fixed attenuator. Another one is variable attenuator. Fixed attenuator and variable attenuator. Okay. So two kind of attenuator are there, and the transmitting horn antenna and receiving horn antenna, two kind of horn antenna are there, and both are horn antenna, and between microwave will pass through it. Okay. And that is the waveguide terminator and output to oscilloscope or the power meter. Okay, these are the things we can see in the microwave systems. Okay, these are the some applications of microwave. See, microwave band ranging from 10 MHz to 10 GHz are capable of freely propagating through atmosphere. It can propagate through the atmosphere freely. The microwave band ranging from 300 MHz to 10 GHz are capable of freely propagating through atmosphere. So it can use in the satellite communication. So mobile communication, another application. Microwave oven, radar, ATC actually, air traffic control. In the air traffic control radar, we can use the microwave. We can use the microwave. And see, that is the antenna and wave propagation. Ionosphere. So that is the transmitting antenna and this is the receiving antenna. That is the Earth and it is the ionosphere. Okay. antenna and wave propagation. That is transmitting antenna, that is receiving antenna. See, this kind of wave is the surface wave. This kind of wave is the surface wave. And that is the direct wave. And that is the sky wave. Three kind of waves are there: surface wave, direct wave, and a sky wave. Okay. Microwave and millimeter wave. That is the satellite communication. So in the satellite communication, we have this privilege. We have this privilege. You can use all waves cannot go through the hemisphere. Only microwave and millimeter wave can pass this. Okay. And we can use the repeaters. That is the terrestrial communication. 50 kilometer at 25 feet antenna. Every 50 kilometer, there is a repeater, and the height of the antenna is 25 feet. And some applications are there, like these are the applications in a short. Communication application, terrestrial, satellite, radar, civilian and military, industrial and biomedical, heating. Okay, those are the applications. And some components are there. These see microwave sources. So these are the sources: magnetron, classroom amplifier, solid state transmitter. I think we can finish here. Okay, we'll see those things in the next class, inshallah. Okay.
Okay, sir. Okay.
Okay, sir.
Okay, so let me take your attendance. Today is the
8.
wait. 8th of September, right? 8/9/21. Roll number 1, 2,
Yes, sir.
3, 6, 10, 12, 14, and 8. 17 also there. Hamid.
Yeah.
So let me check. Roll number 1, 2, 3, 6, 10, 12, 14. Okay.
Yes, sir. 12 present.
Yes, 12, 10. Okay, thank you.
Okay, sir. Thank you.
Okay, Allah Hafiz, sir.